Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
ReOrbit is a company that specializes in manufacturing autonomous and internetworking satellites designed for data flow needs in space. They offer software-defined satellite platforms that are flexible and can be reconfigured even after launch, which is quite innovative in the space industry. Joining me today on the Ex Terra Podcast is Sethu Saveda Suvanam, CEO and founder of ReOrbit. And Sethu, thank you for joining me today.
Thanks, Tom. Thanks for inviting me. Pleasure joining you.
Let's start out just kind of with the basics and have you explain the concept of a software-defined satellite and how that differentiates your satellites from traditional hardware-focused models.
Yeah, so if you traditionally look at how satellite industry has been, working way since Sputnik, the first satellite, has been launched, it's been very much hardware oriented, right? Like whenever you're designing a satellite, you start with a mechanical form factor, then you put all your subsystems, into this box, and then the last thing you do is actually you're writing your flight software, your application software, and so on and so forth. But if you keenly follow technological evolution of, let's say, industries that are very similar to satellites, for instance, automotive, computers, mobile, even the fighter jets today, they all started in the same manner, very hardware oriented. But now the core of innovation in this industries come from software, right? Like today, if you buy Tesla, you're not actually buying Tesla because of its hardware, probably some do, but the core value of Tesla is actually the software nature of what it brings. Similarly, the fighter jets today, largely all the fighter jets are software defined, and the mobiles and computers today, when you buy an Dell or a Lenovo computer and open the hood, none of the hardware inside is actually very similar, but they all run similar softwares, which is Windows or the operating systems. So what we do is we are trying to bring similar innovation in the space industry. So instead of starting with mechanical form factors and hardware, we start with software. So we have now developed a stack of software as a backbone to our system architecture. And this is fully developed and de-risked through an ESA program. And then we treat hardware as a commodity. Probably we are the only one space company where we sell satellites, but we don't manufacture any hardware in-house. Whenever we get a customer, we go to the market, buy the best-in-class hardware with a lot of heritage that suits the requirement of a customer. Then we gel all these hardware around our software. The only, let's say, customization we do is like we develop the drivers between the hardware and the software that we have so that they're compatible to stick around our software. And then the system is ready to go. By this way, we bring a lot of flexibility, a lot of cost reduction. But also what we can do is we can actually start developing a lot of advanced functionalities on top of our software framework way before you have your hardware. For instance, our satellites are designed like a flying router. So you launch one, you launch another, all the software protocols that are required to exchange data, exchange information comes inbuilt.
So then how does the ReOrbit digital twin technology work, and how does that benefit your target customers?
Yes, so what we do, so given that it's a lot of, let's say, software-based approach, we have also built a simulation environment, which we could also name it quite fancily the digital twin. But at the end of the day, it's a simulated environment where we could basically run and test our software. So originally, this simulation environment was developed purely to test our internal software works. And now we are also opening up to our customers. So once a customer buys any of our platforms, so they could straight away get access to the simulated environment where the whole actual flight software and the application layers are running on a simulated environment, so that they could start building the operations. They could start, inputting failures way before, they could even actually start building their satellite and start training their ground and operation systems on the ConOps. So this sort of opens up a big time where the customers can train from day one, even before they actually can conceptualize what kind of satellites they would have.
Let's talk about the company and yourself just a little bit, and talk about the founding of ReOrbit and what inspired the creation of the company.
Yeah, I mean, I've been in the space industry before ReOrbit. I started ReOrbit. I've been in the space industry for about 9-10 years. I've come from academic, background. I've PhD. I've done my postdoc, both of which have been on the space industry. Or particularly, I've been, testing electronics for deep space exploration. Spent some time at JAXA as a visiting researcher, and then I took a 360-degree turn and went into the so-called dark side, where I was actually handling sales for AAC Clyde Space, and that was kind of an interesting journey for me because while I was, in the academic career, I was actually looking at quite advanced architectures, particularly on the avionics side. And then when actually was selling stuff, not particularly, the company where I was working in general, I saw like satellite industry was stuck in the Sputnik days. Nothing has changed, in terms of how systems are built in the last 60 years, 60 odd years. Whereas satellites as technology have been becoming much closer to humanity, right? Like today, everything we do have been somehow related to satellites and space. And that's where I felt like there was this huge mismatch between where the industry is going on the overall business side, whereas on technological side there is this, we've been stagnated. So I saw that there was this big opportunity where I could at ReOrbit bridge this gap. And then I'm also a keen follower of technology in general, and then as I mentioned earlier, a lot of industries started this way, but they were very fast to adopt to the growing demands of the customer. Whereas I think as a space industry, we are far more conservative than these industries. And that's where I felt that, we wanted to be, as ReOrbit, be the precursor to bring that change, to take the technology much more closer to where the customers' requirements are.
Talk to me a little bit, though, about being an entrepreneur, and particularly in Europe. Did you find that it was challenging to start a company from the ground up in your experience? And what was it like going out to investors and saying, here's what I want to do. Do you want to give me some money?
Yeah, I mean, I can actually share this very funny story how I closed my first round. So when I did the first round, it was me with a PPT, and I met this investor, Icebreaker, where we had like 5 minutes. He gave me 5 minutes. Time to basically pitch him, and I think I was like 40 seconds into my pitch, and he was like, "Yeah, I get it," and then he sort of left. So I was like, "Okay, this messed up big time." And then he wrote me an email later that night saying, "Hey, I've spoken about what you said to my partners. Can you come and pitch to our partners tomorrow?" So then I pitched them, and interestingly, they actually closed the whole investment round in 12 days from the first meeting to when they gave me the term sheet. So I mean, okay, I'm not sort of rising hopes of how investments are done in Europe, but in general, I mean, for me, I think the strength of what we are doing sort of reflects on how we have largely done in terms of closing investments, but also closing customers. We are 4 years old company, but we've been profitable since 3 years. We've been our revenues have been increasing year on year by almost like 50 to 70%. Last financial year, we have closed the year around 2 million euros. Probably this year we'll close it around 5 million. So this is actually a testimony to what I said. There is a huge vacuum in the space industry today, particularly the technological on satellite technology. We are sort of stagnated 40, 50 years ago of what we are doing, and today we are sort of stagnated, and that's what we are trying to bridge. And I see that there's a huge vacuum, and that helps a lot for us to go to investors and close these kind of rounds. In fact, we did an oversubscribed round in August last year, where we were probably not even looking for an investment round, but things just came together, and then we closed about $7.5 million round. So I think for us as ReOrbit, if you're, what I can say looking back is, if you're at the right time, at the right place, working on the right things will come together. Of course, you have to be lucky, because there are a lot of people working on really great stuff, but they're not just there at the right time and the right place. So I would say we've been quite lucky in that sense. But overall, how is it in Europe? I would say Europe in general has a large disadvantage when it comes to raising money as compared to, say, a typical startup that's based out of US. I mean, in Europe, generally the investors are, I would say, quite cautious, but also optimistic, and they're largely driven by data in Europe. The hype plays a very little role in actually taking big investment. So you have to do far more data driven convincing to an European investor than you would do in an US based investor. So I would say, like, generally startups in Europe are at that disadvantage. But if you get your fundamentals right, I think you should be able to close your round. And in that sense, we've been quite lucky. And also as ReOrbit, we've been quite lucky to get great people. For instance, our chairman of our board is the current CTO and CSO of Nokia Group. We got John Dane, the previous DG of ESA, or John, who built Astroscale, managed UK, and so on and so forth. So we've been able to get a lot of great people, both in our management team, in our board, but also our employees. A lot of them come with a lot of experience. So I would again say it's the testimony to what we are trying to address, the big problem we are trying to address.
Let's talk about that team just a little bit, particularly the folks who you work with on a day-to-day basis, and kind of give me some insight into their expertise in the space sector.
So as I said, so today we are about 55. We are growing quite fast. We actually, whoever is hearing this podcast, maybe I could use this opportunity to say we are hiring a lot of people. So if you're interested, do apply on our website. So today we are about 55. I would say about 60 to 70% of these people have been in the space industry for 15 years or more. They've been working for companies like OHB, Thales, Airbus, ESA. So one thing, from day one when I started the company, we had a very clear recruiting strategy. Anyone we bring should be better than the guy we bought previously. And generally, let's say if we are bringing someone to handle something, some particular aspect of the company, and when we are discussing with these guys, I mean, we should be we should be the least knowledgeable person, right? So that's a very clear recruiting strategy we have, where every time we challenge our managers to bring the person who's better than the guys that they got previously. So that helps a lot. And also I think the team, when you start bringing great people, they're always hungry to bring much more great, good people, right? So that sort of shows up. And then you start building a culture where everyone, knows when you're bringing people with experience, they know how things are done. So they sort of bring the good habits. And then the company starts moving into the direction that we want it to move.
So you recently announced that ReOrbit is going to proceed to the next phase of the ESA incubed program. So tell me a little bit more about that situation.
Yes. So just to give you an overview of this particular mission. So the idea with this mission is that we wanted to demonstrate three things. One, we wanted to demonstrate our software enabled architectures, as I mentioned, the core software stack. So in the previous phase, we have tested the whole software in a hardware in a loop, meaning that we have achieved TRL7, which ESA tested and gave us that this is TRL7. Now we'll be flying that whole architecture in space. Two, we will also actually demonstrate an optical intersat link, space to space, space to ground. And three, we also would demonstrate in-space autonomy when it comes to FTIR and station keeping and so on and so forth. So the idea is that we want to build a system that's like autonomous and flying routers. So this mission would be the first step towards that. And this mission will also host a very exciting optical Earth remote sensing payload as well. Which will open up really, the idea is also to sort of open up the multi-sensing kind of applications when it comes to the remote sensing side as well. So the mission, we have gone to the last stage of it, which means that we will actually be flying this mission as we speak. We'll be soon doing the PDR, and the mission will fly 13th of April 2025.
My guest on this edition of the Ex Terra Podcast is Sethu Saveda Suvanam, CEO and founder of ReOrbit. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Sethu, there's a white paper posted on your website that discusses the benefits and trade-offs of a software-first approach to satellites. So what are some of those advantages and some of the drawbacks?
Yeah. So when it comes to the advantage, as I said, it brings a lot of flexibility, as we previously spoke. It brings a lot of efficiency also, in terms of the digital twin or the simulation environment. And also you could pretty much, develop quite advanced functionalities, which are not possible today because primarily the architectures are so hardware driven. So when you want to build, for instance, applications such as rendezvous, proximity, docking, or in orbit data transfers, these are all driven by software, but they have a strong connection to hardware. But when you're starting as a hardware first, with hardware first approach, you cannot actually start developing the software unless you lock your hardware. And today, some of these applications, you don't have the hardware to actually do these kind of applications. So you're sort of locked by the limitations of the hardware. Whereas if you're starting the other way around, you could always start developing all these applications on top of your software stack or your software framework. And then when and then the hardware comes, you could sort of tailor your hardware to suit these kind of requirements. So you could always be one step ahead of the industry by going this way. And I would say one of the disadvantages, I would say personally from how I see it is educating the industry more than anything, because space industry is very conservative, as you know, probably Tom. And probably it's more conservative than the construction industry and some of the other traditional industries. So in that sense, really, when you're coming with an idea that's drastically different from what people have been used to in the last 60 years, so going to one suppliers and basically saying, look, you don't have to worry because we take all the stuff on our side when it comes to adopting to your hardware, but also going to the customers and saying, look, this is the advantage you get. It requires some convincing. And once you sort of pass that line, I think this is the way the industry will go. And I said again, if you draw parallels, any industry you see today that's accelerating at an enormous growth rate, it's because of software first approach. It's not because you're locked by hardware. And I'm pretty sure in the next 5 years, satellites and space industry will follow this, software enabled architectures.
Are you finding, though, that the satellite manufacturers are protective of their proprietary software? Do they not want you to take one of their pieces of hardware and say, okay, I'm going to rewrite and completely change the way that it works?
Yes. I mean, if we buy it from, let's say that used to be the scenario 10, 15 years ago, where the number of vendors have been very limited. Whereas today, if you took, if you take the number of vendors at every subsystem level, it's a huge, huge industry, right? Like let's take propulsion. Just France, Germany, UK has maybe more than 20, 30 propulsion companies, or probably even more if my number is wrong. So and then you could sort of boil that down to every subsystem. Just, in Europe, you have probably 50 to 20 to 50 subsystem vendors for every subsystem, so, who are purely only focusing on that subsystem, right? And that's where I think this is again a testimony to the industry moving into the right direction, because once you have an industry where a lot of these subsystem providers are coming, tier 2, tier 3 suppliers are coming, it basically means that hardware is almost becoming a commodity. And now,
Right.
you need to bring innovation on the more system architecture level, which is what we are trying to bring. So for us, it becomes much more easier today to actually go to these suppliers, tier 2, tier 3 suppliers, where we can say, look, you don't have to worry, we'll just adopt. And they're actually happy because this also helps their business in a way. If you as a satellite manufacturer are not bothered about manufacturing hardware, it actually brings more business to these subsystem vendors. So they're actually very happy to collaborate with us and take this kind of architectures forward.
So is the satellite manufacturing side of it becoming almost more like the COTS model, the commercial off-the-shelf model, that you just buy a box and contract a company like yours to write the software for it?
Yes, true. Again, to be clear, we sell satellites, right? At the end of the day, we integrate and sell satellites. So
Okay.
if I have to put an analogy, so we are like Tesla, where we sell the car, but none of the hardware of Tesla comes from Tesla. They buy everything, they integrate everything, but then what is Tesla's core IP is the software. The
Right.
software that runs the whole car. It's exactly the same approach. So the core IP of ReOrbit is the whole software that runs on the functionalities that are run, from the software side. But everything other than software is externally procured, and then we integrate and sell the satellite at the end of the day. And I would say to your question, yes, satellites will become almost a commodity, but then the satellite architectures is where it'll be the innovation will come in. So people will sort of buy hardware as a commodity, but not the architecture. So the innovation lies in the satellite system architecture.
Are there environmental benefits to reorbit satellite technology?
I would say, I mean, I'll be lying if I say like this is addressing 100% sustainability, right? Like that's not the case. Like people will launch satellites and we cannot stop launching satellites.
Right.
So then how do you then start making systems in a much more environmentally sustainable manner? Is, then opening up, once you start opening up the satellite to share resources among each other, then you're in a way effectively utilizing your satellite in a much more, much more, or what do you say, efficient manner. Primarily because today, let's say when the satellite is either partially defunct, and if the payload is still working, you're bound to throw that because maybe certain systems are not working and you cannot no more send data. Whereas if your satellites can transfer data, so you could still extract some meat out of the partially defunct satellite and still put that into use. Or for instance, let's say if you have a satellite which is basically working at 60% efficiency because you're not, hitting the ground segment at every given point of time. By connecting every single satellite, you're ensuring that the efficiency of the satellite overall in a system is actually increased. So you can extract a lot more from one satellite than you could get it when it's in a network, then you could get it as a single satellite. So I would say like our environmental benefit comes from the fact that the efficiency of the satellite is largely increased, which then in turn can potentially make sure that your resources are optimized in a better manner. But at the end of the day, you still keep launching satellites, and that's not something we address.
So when you launch a satellite, excuse me, for a customer, does the satellite then belong, as you say, you sell a satellite, but does your business model include a reorbit satellite constellation where you can then say, okay, we've got these satellites, we can make changes in the software and change what we do, and then have a stream of customers? That way you would be able to reuse a satellite over and over and over again and maybe help reduce the occurrence of space debris.
I would put it this way. So the business model is very simple. So based on our architecture, we have two product lines. So one, we have an Earth observation satellite. Two, we have a geo telecom satellite, small geo telecom satellite. So these are our two products. So we sell two satellite products. So let's say if a customer wants an optical based payload for an Earth observation, so we have one. Or if a customer wants a small geo telecom satellite, we have one. So we basically sell satellites like Tesla sells cars or any other vendor sells cars. But the advantage that they get is because it comes in with a lot of additional functionalities such as autonomous operations, ability to support inter-satellite links as a default. So they can then optimize their constellation to be much more efficient overall than actually having a constellation that are not connected with each other. So on a constellation level, if companies are buying our satellites, so they would get far more efficiency because they can start transferring data and building a much more robust system in terms of total data transfers.
So how updatable then are the reorbit systems, and are they autonomous and then internetworking?
Yes. So we would, I mean, again, it's no system is fully autonomous, right? Like if someone claims it's fully autonomous, then they're lying. So I would say we are trying to get as autonomous as possible within the limitations of both the hardware, but also the environment that it puts. And also autonomy is something that builds as we grow. Of course, these are machine learning models. The more we launch, the more data we get, the more we learn, in the real environment, and sort of we update our satellites. So today, the UCO, the mission that we launched for ESA, we will test our core autonomy modules and the core internetworking modules, where we will have an optical intersat link to transfer data in space and from space to ground. So this is sort of the building block for us towards getting as autonomous as possible and also towards getting as interconnected as possible.
Couple of questions more, and then I'll let you go. But I want to find out what some of the biggest challenges are you faced in the space commerce industry and how your company has overcome them.
So one of the biggest challenges in the space industry today is, let's say, I would mainly say that today there are a lot of governments who are coming into the the space industry, right? Like there's a lot of requirement driven by the governments, and geopolitics is a very big challenge.
Mm-hmm.
And I don't know if we should call now multipolar or how many multipolars there are there in the in the global scenario. So at the end of the day, I mean, especially for a company like us where governments are our primary customers, because geo-telecom satellites are largely driven by governments. So basically understanding the regulatory, basically understanding the geopolitics of it and so on and so forth becomes a big challenge. And we are sort of countering that by bringing people who've been in government before, who have experience running, public offices. So we are bringing really quite experienced people so that they could help us really navigate those scenarios. But at the end of the day, I would say that's one big challenge. And two, I think I've already mentioned, when you're taking an approach at the system level that's completely different from how the industry has been working, then also educating the industry as such becomes a challenge early on. But I think we have nicely overcome that, and now we are having really big names as our customers who are actually trusting us and buying from us, and also we have big names in the industry are joining us. So I think we are slowly overcoming that challenge. But geopolitics is always a challenge for us.
Just one thing more, Sethu, and I'm going to ask you to put on your prognosticator hat and look out, if you might, over the next 10 to 15 years in space commerce and the role of ReOrbit in that, and tell me what you see.
Yeah. So I said, going like 10 years or 15 years into the future, we will never think satellite as an entity that can have, one way to send data, right? Like today, this data just goes from satellite to ground and ground to satellite. So 15 years, 10 years later, I think we will start talking about distributed architectures in space. Like every satellite is connected to everything. And people will no more talk about selling satellites based on application, but charging satellites based on the data rates. For instance, today, if you buy a cell phone, you don't buy a cell phone because it takes picture, or you don't buy a cell phone because you can talk and use it for internet. You buy a cell phone that does everything,
right?
Because everything is connected and your architectures have evolved. So 15 years later, I would imagine you will only buy satellites because it can carry 100 gigabits per second and transfer 100 gigabits per second, or a smaller satellite that can only do 1 gigabit per second. And people will start charging, prices per satellite, not because of the size, because of anything, purely because of the data rates that it can do, so that everything is connected, the data are freely flowing, and then we are moving more towards, the same type of business models that we know in the mobile industry and the computer industry.
Sethu, we're out of time, but thank you so much for joining me today on the Ex Terra Podcast. It's been very interesting.
Thanks, Tom. Pleasure talking to you.
Sethu Saveda Suvanam is the founder and CEO of ReOrbit. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Google Podcasts, Audible, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss any of our podcasts or any of our other videos. You can get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at XterraJSC. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo. The proof is looking glass. Thirst for reason. Our dreamer's eyes we gaze into a sense of purpose, known by few. Like finding water on the moon.